So we're not getting filtration overall from our glomerulus into the capsule. So this is related to something called the GFR, the glomerular filtration rate. So this is how much fluid filters through the glomerulus over time. So the average GFR, well, it depends on your sex and also depends on genetics as well, but and also age as well. So the average GFR in adults is around 90 mils per minute. So in your kidneys, you're filtering about of all the glomeruli and renal corpuscles in your body, your kidneys are filtering about 90 mils per minute. Now, why is it important? Well, the thing is that this is one way we measure kidney function. So it's not only just about whether you have kidney enzymes in your blood or not, but it's also a quantitative way of measuring how much kidney functions you have. So if you have a GFR that's 90 or higher, so again, 90 is that rough average, that means you have healthy functioning kidney. But if this GFR starts to drop, that means your overall ability and the rate at which you make urine is dropping as well. So kidney damage and disease, if you start poking holes or if you have like imbalances with the pressure inside your glomerulus, or if you have problems like say you're losing or dehydrated or other fluid balance problems, that can also affect your GFR. But usually it refers to like some sort of kidney damage and disease. And what's that going to do? Well, if you're filtering it at a slower rate, think about it this way. What if for garbage collection at your house, like say instead of them collecting it weekly or twice a week, they started to collect it once a month. What would happen to the waste in your neighborhood and your household over time? It starts to build up in that localized neighborhood, right? So this is why GFR is important. You want your kidneys to be able to function and get rid of waste at a rate that prevents waste from accumulating in your body. So again, reduce excretion of drugs and xenobiotics. Xenobiotics is a term referring to chemicals that are foreign to your normal physiology. And let me do a visual example. And we are over time, but I'll end on this part, so a little like visuals. So again, afferent arterioles, these are leading to a renal corpuscle. And then we have our glomerulus here, and then we have the efferent arterioles leading away from the glomerulus. So what happens, and I'm drawing it just as like this, even though whole pills won't travel through your capillaries, this little pill is representing some sort of toxic drug. Now this toxic drug is, what should happen is that your GFR and the hydrostatic pressure, your overall filtration should drive this drug from your capillaries into your PCT and your urine. Now, say you have a higher dose, maybe you have more of this toxic drug or chemical. What can happen is that if that GFR, if you have healthy kidney and you're not taking more than the recommended dose, it should be able to filter it from your glomerulus into your nephron. Now, what happens if you have that same high dose, but your GFR drops off? Well, now you notice that with the less of a rate and a reduced rate of moving toxic substances from your blood into your filtrate, now we still have these drugs left over when they end up in your efferent arterioles. The good thing is that there are other places in your nephron that you can secrete toxic metabolites through, but what I'm getting at here is that compared to the previous example with the high GFR or normal GFR, that lower GFR is going to impede your ability to get rid of toxic waste and metabolites. So this is why GFR is important. You don't want waste and metabolites accumulating in your body.